This is number 9.
From Weber sign, okay.
Yeah, this is 3.2.
3.2.
So they have the question as f of x equals the square root of the quantity 3x cubed. Or sorry, it was 2x cubed.
No problem.
2x cubed minus 32x. All over it.
Okay. Okay. And the question is asking us to find the domain?
Yes.
Okay. So let's find, bless you. Yes, and this is a very good question, because what was that question we talked about it last time? If you remember, I said, please remind me to do it. Okay? Okay. Very good. So please remind me about that. But this may cover it, and if it covers it, it's fine. This is actually a little bit more complicated than the one we looked at last time. And Caleb, thank you for asking about this, because I would have forgotten. So my apologies. So of course, what is the condition that I have to write?
Restriction.
Yes. What is it?
Must be greater than 0.
Okay.
So
What?
that entire. So yeah, that quantity.
Just the inside. I want to make sure that you are not giving me the square root, right? So the condition is that this quantity has to be greater than or equal to 0, not the square root. The square root will always be a positive number. So please be careful, just the quantity under the square root. Okay, perfect. So now this is a polynomial inequality. So we have to be very careful with this. We can simplify both sides by, and I will always do it, never by x. But this expression can be, or this inequality can be simplified, dividing both sides by, indeed, yes. I don't care for that too. It's x cubed minus 16x greater than or equal to 0. Awesome. That will not change the sign. It will not affect the answer. Now, of course, I will factor x, and then I have x squared minus 16, and then I will have to continue factoring, and we know how.
X minus 4, x plus.
Excellent. And now, please do not confuse the table that I'm going to use next with what we covered so far, because we have not seen this before. It will look similar, but it's not the same, okay? This table is used to, so table, to study the sign of an expression. The other tables that we looked at were a summary of absolute value expressions. They were totally different. So please do not confuse this table that I'm going to use next with anything else that we've covered so far. Okay. How many factors I see here?
3.
Of course. This is the first factor, this is the second factor, and this is the third factor. What is the variable in the problem?
X.
Of course. The first row must always be the variable. In this case, it's x. It goes from negative infinity to infinity. Then I'm going to list each and every factor I see for with its own row. And then here, because of course I ran out of room, I'm just going to say the product. But you should write, if you have room, x times x minus 4 times x plus 4, because that's the product. That's the product that I'm talking about. It's just that I ran out of room. Okay, now I would like someone to tell me when is this 0? For which value of x is this 0? For what?
Just 0.
Of course. Which value of x is this 0?
4.
For which value of x is this 0?
Minus 1.
Excellent. I need them in ascending order. So tell me these three numbers. So you gave me 0, you gave me 4, and you gave me negative 4.
Negative 4, 0.
Negative 4 is 0, 4. Awesome. Now, I'm going to ask again. I know it's silly, but I just want to take it slowly. There is a 0 for x under some number. Which one? I know it's silly to even ask.
0.
Under 0. There is a 0 for x minus 4 under one number.
Yeah.
Under? Under 4. Good. And there is a 0 for x plus 4 somewhere. I know it's silly, but I just want to make sure you're following. Correct. Now, please tell me what happens here for the entire product. Under -4, what happens for the product? And the 0 and under 4, what happens for the product?
Each of those are going to be 0.
Of course. If any of those factors is 0, of course, the product will be 0. No questions. Asked here. Good. Okay. Now, look at these three and tell me what type of functions are they. So what type of function is this? What type of function is this? And what type of function is this? They're all linear functions, right?
Mhm.
How many different possibilities we have for a linear function to look like? I know I look silly, but if it helps you, I'm happy. So this is one possibility. What type of slope is this?
Positive.
Awesome. It comes from negative values and goes to, and of course it crosses 0 somewhere. Okay, what about the negative slope? It comes from,
Positive,
it goes to,
negative,
but all these have what type of slope?
positive.
Good, so you know the sign then. You already told me the sign. Before 0 is negative, after 0 is positive. That's you. All have the same sequence of signs. Now, how many subintervals we see here? One between these two, one between these two, one between these two, and one over there, right?
Mhm.
So in the first subinterval, this is a product. I multiply a negative by a negative by a negative. What is the sign?
Positive.
Yes, 3 negatives, negative. In the middle, I have 2 negatives. Don't even look at the positive. It's not going to make any difference. Sign.
Positive.
In the next step, I have only 1 negative. Sign. And the last one, there is no negative. Perfect. So now, only now, I look at this and I ask myself, what am I looking for? Which sign is greater than or equal to 0? Which sign is greater than or equal to 0? Of course. Is the product ever positive? Is it ever positive? For which x values? And that will be the solution. Let's write it. Since the equal symbol is here in the inequality symbol, what will you say? X in the interval. I'm ready for you to give me the answer. -4 to 0, what type of interval?
Positive.
Yeah, bracket.
Good. Union? Yes. This is the method I suggest. If in the past you learned an easier method, use it. Of course. So coming back, this is a domain actually. Or x in, or this is a domain of this function. Last time we worked on a different problem from the handout, but this is much better than what we looked at. That one had only 2 factors, and it was a quadratic. This is a polynomial, more sophisticated. You have more information here. Perfect question. Perfect question. So one more time, this was a table that enabled us to study the sign of an expression. As you see, signs. This is not the table we used for absolute value.
Is that the easiest way you know how to do that?
Yes. Because of the parentheses and the brackets, there is a method in your book, and you can look at it, and it shows just check here and put a number and plug in a number and come up with the result. It's a perfect method, but I think it's way more cumbersome than this one. Here, once you establish the sign, you're done. You don't have to plug in anything. So what they do is they determine these numbers and then they take -5 and they plug it everywhere to see if it's positive or negative. And then they take -2 and they plug it everywhere to see if the result is positive or negative. So if you prefer that, please use it. It's a perfect method.
So if it was more than 0, we'd have to look for the negative signs.
Say it again.
If it was more than 0, then we have to look at negative. The other way. If it's less than 0, do we have to-
Oh, if it's less than, yes, less, what sign is less than 0? Right, so we would take this and 0 to 4. Correct, yes. Anything else? Do we have other questions? Yes, Glenn?
On what the sign.
Okay, I don't have it, of course, so you have to give it to me.
So it says suppose the range of a function f is in brackets -3, 6. What is the range of the absolute value of f of x?
So f of x is the absolute value of x, I'm assuming.
No, it's f of x is inside the absolute value.
Oh, so it's like this.
Yes.
Okay, perfect. So then, what are we asked again?
Find the range of -3 to 6 in brackets.
So you're saying x is an interval between -3, 6,
Yes.
and we want to find the range of this?
Yes.
Are we given a graph?
No.
I have to bring it up. I'm not sure I understand what the question is asking.
I think I had f of x, the range is that domain. The brackets is -3 to 6, and it's asking for the new range when it's an absolute value of f of x.
Oh, so this is not the domain then.
That would be the domain of the first function. F of x.
Let's take a
I
look.
remember that one.
What's this?
It takes a blink for me to log in, so let's take a look quickly.
Yeah, no, those will be in. This just won't be the same.
And you said in 3.2?
Yes.
Okay. Oh, I didn't mean to do that. I meant to view. And the problem is number 19. Suppose the range of a function, so it's not the domain. So that's very important, right? Okay, I see now. So this is not, quiet please. So this is not x, so this is y. Y is in this interval, -3, and I got 9, so I'm gonna work on your problem, right? So if we have a function whose range is -3 to 6, and we want to determine the range of the absolute value of x, imagine on the real line, we have the range between 1, 2, 3, 1, 2, 3, 4, 5, 6. So the range is between -3 and +6, correct? Okay, so whatever function. Well, this piece from -3 to 0 will move when we use the absolute value. So for example, maybe it's better if I give you an example like this. Okay, so here's x, y equals x, right? So if I have now the absolute value of x, which is the absolute value of this function, what happens is the negative portion moves here. This stays where it is. But now this, the red graph will be the absolute value of x. The black graph is just x. Right? So the range here was between -∞ and infinity. When I flip this to the positive side, the range became 0 to infinity. Clear? So when I have between -3 and 6, the portion between -3 and 0 will get flipped between 0 and 3. But you still have 6. So the new range will be between 0 and 6. Because the portion between -3 and 0 will not exist, will move here between 0 and 3. This portion that was negative, now it becomes positive. So you have between 0 and 6 as your range. Is that better? Good. Anything else? Good questions. Anything else?
Can we actually look at, if there's time for one more, just an absolute value, problem from the other day?
Yeah.
Possible? Okay.
Yes.
So it was just one of those final piecewise notation. So it's the absolute value of x squared plus 3x.
Say it again. I'm so sorry. I was checking if
I'm sorry, this was on the absolute value.
Okay.
From the other day.
Yes.
But I just wanted to ask this.
Yes.
So it's number 11.
Yes.
And it is the absolute value of x squared plus 3x.
Right. So now you have the information because you will have two options as x squared plus 3x for x squared plus 3x greater than or equal to 0, and the other option for x squared plus 3x less than 0. And now you know how to solve this based off that table. You will factor and use the table. Now you have only two factors. You will have x as the variable in the problem. You will have factor x. You will have factor x plus 3. And then the product. Exactly what we did here. You will have x and x plus 3, just 2 rows, and you determine the product. Is that clear? It's exactly the same problem. That's the one we looked at. Good. Anything else? Is that good enough? Yes? Okay. Is there anything else before we look at rate of change of a function? Section 3.3. Anything else for me? Okay, 3.3, rates of change. So here's the general definition, and then we are going to look at something very important called the difference quotient. So let's suppose we have this function which is f of x, and we have a point, I'm going to call it point A, and we have a point, let's call it point B. And of course this is x1, and this will be x2. Can anyone give us the height here, or the y-coordinate of A and the y-coordinate of B? Say it again. True, I want it another way. It's nothing wrong with y1 and y2, but I want something else. Nope. If a point is present on a graph and its x-coordinate is 5, how do I find the y-coordinate?
You do 1 and 2 minus 1.
No. So if this is 5, how do I find the y-coordinate? And I know the point is on the graph of function f of x. How do I find the y-coordinate?
You plug it into the...
Correct. So it will be f of 5. So now I don't have 5, but I have x1. So what will be this height? Excellent. That's all I want you to remember. Okay, perfect. And what about this height? Of course, it makes sense. We know that. Maybe I didn't ask it clearly. So the average rate of change for this function between A and B would be nothing else but the slope of this line. It's called the secant line. It's not the function called secant that we will talk about later. It's the secant line. Let me just write secant line. Can anyone give us the average rate of change between A and B? Which is the slope of this line. Awesome. Very good. Perfect, Ryan, thank you. Okay, so let's pick a function. I like to practice this just on a simple function. And I'm looking in our book to see if they give us a simple function, and they do. Here it is. Please choose any function you want. they indicated 30, but we can choose any. So any function to find the average rate of change between the interval or on the interval -4 to, or
34.
we want to look at 34. Perfect. So let's work on 34. So this is 34 on page 208 from the book, of course. And the function is k of t, which is 6t squared plus 4 divided by t cubed. And they are giving us the interval -1, 3. Perfect. Okay, so the average rate between -1 and 3 will be, by definition, f of good minus f of excellent over 3 minus -1, which is 4. So what we have to do then, I have to find f of 3, which is 6 times 9 plus 4 divided by 27. So 54 plus 4 over 27. Have to multiply 27 by 54 and add 4. And my calculator just died. Oh. I see why.
Would it be KF?
So how much is it? So 54 times 27 and plus 4. I got 1462. Correct me if I'm wrong. Over 27. Yes?
Sure.
Right? 6 times 9 plus 4 divided by 27. 54. That's what I got. Now we have to determine f of -1. Right? So f of -1 is 6 plus 4, which is 10. It's minus, yes, you're right, because it's to the third power. So it is indeed 2. I'm going to delete that. It's x cubed, t cubed, yes. Good. So now let's determine the average rate. So from here, I'm going to jump here and write 1462 over 27 minus 2 divided by 4. Any questions? Are you with me? Any questions? Okay. So then this is 1462 minus 54 divided by 27 over 4 over 1. And what do we get at the top? I got 1408 over 27 times 1 over 4. Let's see if I can divide this. Yes. So this will be 352 over 27. And I cannot do anything else to it. I want to caution you on, in this particular case, the function was abstract. X was abstract. It didn't have any meaning, specific meaning. But always remember, there must be a measurement unit here. When we're looking at a word problem, if you're calling me and you're asking me, what are you doing? I'm saying I'm driving, and you're asking me, what is your speed? I'm not going to say that I'm driving at 40 miles. That's the rate of change of distance with respect to time. But I would say that I'm driving at 40 miles per hour. So the rate of change, remember, has 2 measurement units. The rate of change, measurement unit, is a ratio, like miles per hour, like kilometers per hour, like number of units per hour or per minute or per year. So the measurement unit is always a ratio. for the average rate. And now I would like to talk about something very related to this. I can't wait till some other section. It's called the difference quotient. Very, very similar, you'll see in a moment. The difference quotient. We will determine it for a couple of functions, and I'll explain what it means first. Let's go back to the same type of function. Actually, any function, it doesn't matter. Here is the function, it is f of x, where I'm going to call this point P, and I'm going to call this point Q, and I'm going to ask you to give me the y coordinate of point P. If its x coordinate is x, of course, it will be f of x. Now, careful here, Q is a point this close to P. So I'm literally zooming in, because I can't show you anything if I show you that Q is here, right? So the x coordinate of Q is x plus a little bit. That little bit is denoted by lowercase h. So imagine that P and Q are very close to each other. P has coordinate x and Q has coordinate x plus a little bit. Of course, I'm going to ask you what? Very good. Indeed. And the same thing as before. This is the secant line PQ. I would like you to give me the slope of this. And that will be the difference quotient. Yes, I'm ready. The difference quotient or the slope of PQ. Very good. So x plus h minus x, and we simplify, and we get f of x plus h minus f of x divided by h. Do we remember this?
Yes.
Okay. I would like us to look at two functions. One that is a radical function, and another one that is a quadratic function. Have we determined the difference quotient for other functions before? No. Okay. So, what does it mean? It's still the rate of change. It's still the rate of change of the function between 2 points, but 2 points that are extremely close to each other. So when we say that it's almost the rate of change that is instantaneous at that point. Almost. Almost. So this is a rate of change between 2 points that are very close. Mike?
Why wouldn't it still be x, like x1 and x2, like it was on the other
Because,
side?
very good. Because here we're really interested in the slope of the tangent line. We're not really interested in the slope of a secant line. Yeah. So as I bring Q closer and closer to P, little h gets closer and closer to 0, and the secant line becomes the slope of the tangent line. And becoming the slope of the tangent line, but that's for calculus. Becoming the slope of the tangent line can determine the rate of change at the point which we're in algebra we can't.
And
The rate of
tangent
change
line-
requires 2 points. Say
Tangent
again?
line would be connected just by 1 point, and the secant
The
line would be
tangent.
connected by at least 2.
Yes, yes. The secant line crosses the graph in 2 points. The tangent line will only touch the graph in 1 point. And that will give us the instantaneous rate of change. So if you ask me when I'm driving, what was your average speed? I'm going to look at the distance, I'm going to look at the time, I'm going to say where I started, f of x1 minus f of x2, or x2 minus f of x1 over blah, blah, blah. But if you ask me, look at your odometer and tell me exactly what does it say at that instant, that is the slope of the tangent line here. The instantaneous rate of change at that point. But again, don't bother with this because this is for Calc 1. So, now let's choose two functions. Let's choose a radical function and let's choose a quadratic function. We can also choose a rational function and look at the difference quotient. I'm ready when you are. Okay, x squared minus 3x plus 4. And let's say the square root of x minus 3. And the last one, let's say x plus 1 over 2x minus 3. So we're asked here to find and simplify the difference quotient. So let's write the question so we know what this means. So this, find and fully simplify the difference quotient for these functions. Two things happen every time I find the difference quotient for any function. Two things, I'm going to write this down for you. Every time you're giving me a function and you're asking me to find the difference quotient for that function, I know that two things have to happen. If they don't happen, I know I have to go back to the drawing board. I made a huge mistake somewhere. So in the numerator, over there, all terms, I'm going to write this down for you. You don't have to write it down right now. So all terms in the numerator that do not have h must go away, must simplify somehow. And the second thing that has to happen, this h in the denominator must go away. For any function, anytime I determine the difference quotient. All terms at the top without h must go away, and eventually the h in the denominator has to go away. There must be an h left in the final answer. It will be, but not the one from the denominator. Okay. You do not have to memorize in this class the difference quotient. It will be always given to you on a test or final exam. In the next class, you have to remember it. You have to memorize it. It's not a big deal, but you're not asked to memorize it now. Okay, ready? What do I have? So we are looking at the first function now. We're looking at f of x equals x squared minus 3x plus 4. I see three entities here. 1, 2, 3. Which of these three entities I have and I can change and there is nothing I can do to it? Of course, there's nothing I can do to it. Just a little quantity. There is nothing I can do here. Good. Which other one I can't do anything to? Of course, f of x is, no, f of x is done. There is nothing I can do to f of x. It's carved in stone. So these two are carved in stone. This is the only one I don't have. So please dictate how we determine that. I have to determine f of x plus h first before I put all these three pieces together and simplify fully. I'm ready. Of course, yes. So please tell me how to do that.
So x plus h
In parentheses, right? Good.
and minus x plus h.
Great job. Well done, both of you. Excellent. Now you're going to give me how many terms for this?
X squared plus 2xh.
Thank you. We have an agreement. From the very beginning of the semester, we signed an agreement on x plus h squared. Well done. Thank you. So now this quantity is fully simplified. So now I have this, and I have this. I'm ready to put all these three pieces together. So I'm going to write the equal symbol here and continue on the next page. As you see, I've always run out of room. So the denominator is h. I copy all this. Oops. I copy all this in here. So x squared plus 2xh plus h squared minus 3x minus 3h and plus 4. I reached this stage which tells us to distribute -1 to all three terms in f of x. So please dictate.
So x squared.
Yes?
3x
Yes?
plus 4.
Minus 4. Very good. And now let's write a note. Here's our first note to ourselves. All terms without h must go away. You cannot fabricate that. You cannot just cancel them and say it doesn't have age, go away. No, right? I'm trying to be funny. I'm not successful, I know that. Okay, so here it is. Positive 3x, negative 3x, positive 4, negative 4. Are they all terms without age, are they gone? Yes, they simplify because x squared, negative x squared, and 3x and negative 3x, they are going away. How many terms are left at the top? 3 terms. Good. So that was our first note. So all these 3 terms have a common factor. Can anyone tell us what? H. What is left in parentheses?
2x plus h minus 3.
So here's what I do next, and this is our second note. This is our second note. What is our second note all about? What should it read? Help.
2x minus 3 plus 8.
The second note should say that at the end, h from the, yes, will go away. If note 1 and note 2 do not happen every time I address this issue, I made an error somewhere, I have to go back and start from scratch. As you see, there is still a term with h left over. You will see in calculus what happens with that. Not here. So this is done. So what does this represent? What is this all about? This is the difference quotient for the function to be selected. It gives the rate of change of that function between 2 close points. And if you make h 0, it gives you the instantaneous rate of change at that point, p. How will you feel about this? Okay, so do we want to do both, or you want to choose one? The square root? Okay, very good. So the same question, this time we have the square root, I think I said x minus 3. And we want the difference quotient. Please write the difference quotient first, the formula. F of x plus h minus f of x divided by h. And now please tell me what to write. F of x is clear, h is clear, but I want you to tell me what to write at the top.
The square root of x plus h minus 3.
So we have the square root of x plus h minus 3 minus the square root of x minus 3. We all agree? Yes? Perfect. So now what do you think we're going to do with this? Can anyone refresh our memory?
Square.
This replace x minus.
So let me address this. We can square it only when we have an equation. I have $100 in my pocket and I said, no, I decided to square it. It can be, right? So if I have x equals 5, I can square both sides. If I have a ratio and I want to eliminate radicals, I have to apply a different procedure, which is multiplication by 1. This is 1. Because multiplying by 1 is not going to change anything. But I need a specific form of 1. Not just 1. I need something that equals 1, but it will do the job. What will do the job? Nope. Because I'm not interested in doing anything to this.
Do you want
Yeah,
square root x minus 3
just change
over?
the sign as plus. And
Correct. We need the conjugate. The square root of x plus h minus 3 plus the square root of x minus 3 over the square root of x plus h minus 3 plus the square root of x minus 3, of course. And that is 1. Because we multiply and divide by the same number or the same quantity. We have not changed anything. This is 1. But now when I multiply them, a lot of things will change. Several things will change. And remember the formula we are using now, or the special product, we reviewed it on the first day of classes. A minus B times A plus B. So please, I'm going to copy the denominator, and you give me the numerator.
So it would be just x plus h minus 3
Perfect so far?
minus 2 times
Careful, that's not that formula. A minus B times A plus B is A squared minus B squared.
oh, you're right, that's better.
Very good. So then we combine like terms. X plus h minus 3 minus x plus 3. I forgot to ask you, what has to happen in the first step?
It will go here.
All terms without
It must go.
must go away. If they don't, we have to go back to the drawing board from scratch. Something is terribly wrong. But negative 3 with positive 3 and negative x with positive x, they do go away. So now, what is the second note that has to happen every time we determine and simplify the difference quotient? What has to happen now? Yes. That's why all terms at the top have to go away so we can pull out an h and simplify with the bottom. So for this particular function, the expression that gives the rate of change between two close points is this. Questions from me here? Yes, please.
Can we apply substitution in the beginning? Like, can we replace x minus 3 by t and then use this method?
No, because you have to plug in x, you have to plug in x plus h. So if you use a notation, you're not going to be able to plug in x plus h.
We don't change this h, we just replace this x minus 3 with t. Like t plus h and then t here and then do the same thing.
Yeah, but then you have to go back and replace it back. The answer has to be an x.
Oh.
Yeah, I see what you mean. Yeah, but the answer still has to be, final answer has to be an x. So we can. Okay, two more concepts in this section before we move on. Local, also called relative. We use them interchangeably. Local or relative, max or min of a function. So here's a graph. And we see that this function, I hope you agree, it's increasing till this point, and then it's decreasing till this point, and then it's increasing. Would you agree with that? I'm just going to put some numbers here. I'm going to say 4. I'm going to say 8. And tell me if you agree. The function increases, not from what value to what value, for any x value between negative infinity and 4, and for any x value between 4 and 8 and infinity. So negative infinity 4 union 8 infinity. And the function decreases on the interval 4 to 8. Notice that I did not use brackets. We're talking about the trend. It's like somebody's salary increased between 2000 and 2010. We don't care from which value to which value. Just the trend. The trend is increasing between 2000 and 2010. So this function is increasing for any x values here and beyond 8, but it's decreasing between x value of 4 and 8. This point is called, this one, point A, is called a relative or local max. So A, relative or local max. What do you think point B will be? Yes, relative or local min. So B, relative min. Now, how do we know that this is a relative min? Because the function is defined on both sides, and I can show an open interval where the function values are smaller than this one, than this height. Here I can show an open interval where the function values are larger than this one. So that open interval concept is crucial. Now let's look at this situation. I hope you agree that the function decreases and then increases. I'm going to say that this is 2 and this is 8 and this is 10. I see 3 points here. I see point A, I see point B, and I see point C. Let's start with point B. Can I show the open interval left and right where all functions values are larger than this height? So what do we call point B then? Yes, relative min. Okay, let's look at point A. Can I show the open interval on both sides? So point A, not a relative or local. The endpoints of an interval could never be relative. But since it's the highest possible value of this function, that will be a global or absolute max. But it cannot be a local or relative because I cannot show the open interval. The function is not defined on one side. What about point C? I cannot show the open interval because the function is not defined on this side. So it's not local of any kind, not max, not min. Is it an absolute min or max? No, because there's other values smaller than it and other values bigger than it. So we'll say C is nothing. Nothing. It's not a local max, it's not a local min. It's not an absolute max, it's not an absolute min. Yes, please.
So I was gonna say, there's no such thing as an absolute min.
For this particular function. For this particular function. I'm sorry, yes, you're right, actually. Sorry. B is a relative min and absolute. Thank you. Of course. Of course, thank you for saying that. Yes, in this case, B is not only a relative min because I can show the open interval, but it's also an absolute min because there is nothing smaller than it. Thank you very much. Very good. So I would like to show, honestly, I really don't want to spend the time on this because we're going to apply this procedure a lot when we get to polynomial and rational functions. But it says here, for the following exercises, use the graphing utility to estimate the local extrema of each function. Local extrema is the plural. Local max min, plural local extrema. Max min of each function and estimate the intervals on which the function is increasing and decreasing. So we can choose a function. Let's look at any of these functions and try to find with the graphing calculator the local max, local min. Now, when we move to calculus, in calculus we don't do this with a calculator. We can do it algebraically for any function, find max min by hand. But here we can't. So I have to show you the procedure. I can show you now, or I can show you when we get to polynomial and rational functions, but you may encounter a problem like this on WebAssign. So what would you like me to do? Okay, very good. So can we choose 37 maybe? Okay, t times the square root of t plus 3. So this is problem 37 on page 208. And the function is g of t equals t the square root of t plus 3. First, before I even grab the calculator, before I even think about it, I have to find what? Always. I have to find the, yes, or the domain, in other words, exactly. The domain is our first concern before we start graphing anything. That's our first concern. Okay, what do I have to write in order to find the domain of this function? I have to write I have yet to find one group of students who likes the square root function in 23 years. What did we just say a few minutes ago about the square root?
Maybe negative.
No, the answer, no.
What's inside the square?
Exactly. So the only restriction is that t plus 3 must be greater than or equal to 0. We discussed that several times. Please, for me, fall in love with the square root function. Please. Please. I'll find an incentive for you if you do. So the domain of this function is -3 to infinity, because I don't want to waste my time. I need to graph it on -3 to infinity. I don't want to see anything else, because the function is undefined, and where else?
But why didn't you take t and set that right?
Well, why would I?
Why not?
But there is no problem. There is no danger. T can be anything. The quantity under the square root cannot be anything. T outside can be whatever. It's free, completely free. Ready? Okay. Yes, please.
This way.
You wanted me to go back?
Just for a second.
What is going on?
That's that one.
What? Don't they have a run?
Say it again.
Oh, it switched to that one instead of that.
Because I pressed the document camera instead of the laptop. My mistake, sorry. Okay,
Okay.
ready? And in the other class I have a different setup. It's a document cam. Here is on the laptop. Okay, so in y equals, we have x, the square root. I always put parentheses, you know me already, x plus 3. So one more time, remember, we only state restrictions on dangers. We don't state restrictions on polynomials, right? Caleb, is that clear? T is not a danger. T is a polynomial. We never state restrictions on polynomials. Okay, and now I want to see the viewing window between -4. I know the answer is, the domain is -3. Okay, to 20 with a scale of 4. And y minimum, I have a cheat sheet here, as you see. So I can adjust, but you don't have that. So, okay, y minimum, I'm not sure. Let's say -4 to +6 with a scale of 1 and see what I get. Okay. It's very clear what's happening here. Although, in order to have a better graph, I will change this to 6 and I'll have a better graph. Here it is. So we're asked to determine the local max, local min. It happens that this is also an absolute min, right? Relative min and also absolute. And now we want to determine it. Okay, so this was -4 and this was 0, correct? So you can simply use the zoom 6 or the cursor, or simply just say second and calc. We want to determine a minimum, so I'm using 3. You can scroll and pass the minimum, that's one option, but make sure you completely clear that minimum. Okay, that's my left bound. And then I can put 0 as my right bound. And now I don't want to guess. I press enter again, and I'll get the answer. So the minimum is at -2, and the y value is -2. So t equals -2, and f of -2 is also -2. And now what will you say about the increasing and decreasing intervals? Remember the function starts at -3. So between -3 and -2, what does the function do? Right, and between -2 and infinity, the function, that's it. That was a perfect example. So I will say -2, relative and absolute min. F increasing on -2 to infinity, and F decreasing on -3 to -2. No brackets here for the trend. Any questions?